Now that you've successfully done the first part of the assignment and added an operator to the simple calc interpreter, we're going to go ahead and make things a little bit more complicated. We're going to add assignable variables. Let me show you an example. So if the user says a equals 5, that's going to return the value 5 because we're going to follow in the footsteps of C and Python and most other modern programming languages, say that assignment is just another expression. But here's the tricky part. When the user uses the variable a again, for example in the expression a plus 3, we're going to have remembered what they assigned to the variable and correctly give the value here 8 of 5 plus 3. So this is a little bit tricky because it means that the interpreter is going to have to remember state between different expressions. When the user assigns a the value 5 here, we're going to have to remember that binding for when they go to use a again in the next expression. Let me go ahead and show you the new full calc interpreter code so that you can see how complicated this gets. So first we need a way to store the values of these bindings. And what we're going to use for that is a data structure called an environment. So an environment is just a map from strings representing the names of the variables to integers, which represent their values. And we're just going to store this as a list of pairs. So a list of string, int tuples. The empty environment is the empty string. To delete a binding from an environment, we go and walk through all the pairs, and if the name matches, we just don't include that binding in the new environment. The new list will not include any bindings for the name that we're deleting. To add to an environment, we delete any current bindings for that name, and then cons a new binding for that name onto the beginning of the list. And then finally, to get a value, we go ahead and look through the list, find a value where the name matches, and return the find a entry where the name matches, and then return the value. So once we have environments, the question is, what do we do with them? And the answer is that we're going to have to change the way we evaluate things. Just producing the value of an expression isn't good enough anymore. We're going to have to carry around the environment with us. And if we do an assignment, we're going to have to change the environment. So let's go ahead and take a look at what that looks like. So here are some helper functions that let us evaluate binary operators. So if we want to evaluate an operator, op, with two subtrees, A and B, in an environment, we get the value, which is the left subtree's evaluation, the operator, and the right subtree's evaluation. But we also have to return the new environment. So the value of our evaluation function now isn't a number, it's a number and an environment. So here are all of our cases. To evaluate a number in an environment, you return the value of the number and the environment unchanged. The evaluation of a name is we get that name out of the environment, and then we return the environment unchanged. All our familiar Boolean operators are binary operators are binary operators. We're adding some new Boolean operators because the assignment's going to have to do with adding ifs or adding while loops, which requires conditionals. I give you if statements, so you should be able to extend that to while loops pretty easily. Here's the new trick. The equals operator gets parsed into a set value, and the left-hand side has to be a name. If we try to set something other than a name, then the program is poorly defined and we can't really evaluate it. But if the left-hand argument of a set is a name, then we can go ahead and update the environment with a new binding, with adenv, and return the result of evaluating the right-hand side as the value, and the updated environment as the new environment. Here's if statements for the fun of it. And we have to change our read loop. It has to carry around a state in addition to the prompt in the function. And it goes ahead and threads that state through its recursive calls. It updates the state potentially with each line of input, and then passes it on through to the next iteration of the loop. Our eval print function also has to do the same thing, passing in the state and keeping track of it, potentially updating it. We print only the value. We don't show the state to the user, but we remember that state all the time. And that's the only way we can handle things with side effects, is to have an explicit state that tracks what the side effects are changing. And that lets us have assignable variables.